Good morning, everybody. I think we can get started. First talk of the day, bright and early. So we're going to talk about microservices testing, and in particular, some of the things that can go wrong, and some of the ways that you can maybe pull it back and get on the right track. So my name is Holly Cummins. I work for Red Hat. I'm an engineer on the Quarkus team, so I help build Quarkus. But we're not really here, we're going to show Quarkus, but we're not here to talk about Quarkus today. Before I joined Red Hat, I worked as a consultant, and so I spent a lot of time with clients, sort of seeing how they were using microservices and going, oh dear, oh, that doesn't seem like a very good idea. Oh, no, oh, that's going to end badly. And I was, a senior consultant, so I would get flown in if a project was in trouble. And one of my first microservices projects, I kind of got off the plane, and pretty much the first thing they said to me was, every time we touch one microservice, all of the others break. And I thought, I'm fairly sure that when you read the microservices manual, it doesn't say every time you touch one, all the others break. I'm fairly sure it says that it makes it easier to change them independently. What's going on?
Yeah, but then my name's Deandrea, and I work for Red Hat as well. I do have the T-shirt to say I helped make Quarkus, but I'm not an engineer on the Quarkus project. Like every good open source project, or every good open source project out there, you can be part of whatever communities you want to. I do have the privilege of working for Red Hat as well, but kind of along the same lines with what Holly was saying, I worked mostly in financial services before joining Red Hat, and we had the exact same problem, but the answer was, oh, we'll just do more end-to-end testing. We'll just get everything in an environment and hit the load. But then, I don't know how you all operate, but we did quarterly release cadences, and so trying to get the stars to align on the 5th Tuesday of every month when there was a full moon and the tides were high so that all the teams could align was a real challenge. Anybody else experience that kind of problems? It's a couple hands. Yeah, so trying to do this end-to-end testing was really hard and really expensive for us.
Yeah, it's your microservices are breaking. The solution is to do end-to-end testing, but end-to-end testing is too expensive, so you can't do end testing. Well, then what am I supposed to do? How am I supposed to make this work?
And quick shameless plug, so I've also written a book. We're going to do some free giveaways. I'm going to do book signing giveaways at the Red Hat booth at 10:50. Unfortunately, not everybody's going to get a copy. Not everybody's a winner. I've only got limited copies, but it is free to download. I don't make any money, so by all means, please come by and see me, and happy to sign a book for you. Shameless plug over.
I recommend this book to everybody, because if you're using Spring and you sort of want to know what it looks like if you were to go to Quarkus, then that is the answer. So we should add as well sort of a bit of a disclaimer. I always feel a little bit nervous when I talk about testing, because I'm not a professional tester. Tester is not anywhere near in my job title. And really, I don't even think I'm a test expert. I wouldn't say I'm a test specialist. But the thing about software engineering is if you are a software engineer, you are a tester, or at least you should be, because this is such an important part of what we do that we need to be paying more attention to it.
But it's hard, right?
Yeah, it's super hard. There's such a gap between oh yeah, I should do more testing, and I have a deadline, and I'm doing all these microservices, and then it just sort of goes wrong. And I think it goes extra wrong for microservices. Because if you look at something like the Netflix microservices architecture, so here you've got quite a few, that's not a moon.
That's your architecture.
So there can be some unexpected surprises when you try and do these really complex systems. And what seems like it's really simple if you look at it in isolation, when you look at the whole picture, is actually incredibly complicated. And so then this sort of means that often we're told, oh yeah, you should go to microservices. Microservices are going to solve all of the problems. But when you look at something like the Netflix Death Star diagram, you think, actually, I'm not really sure it's solving all of my problems. And when you look at the sort of the dynamics of the system, again, you know, there can be some really unexpected, unpleasant behaviors. And something that seems like it might be okay if you look at it kind of when it's not moving, when it starts moving, and when you look at the dynamics of the system, it starts to become really quite scary, a bit like transporting Rathtars.
Yeah, but at least this time for Han, it actually solved all of his problems because it ate his enemies. Typically, the microservices don't solve the problems on their own.
And microservices generally do not eat your enemies much as we wish they would. So going back to this kind of diagram, I think often when we think about testing microservices, we think about testing an individual microservice in isolation. And we say, oh, it's really small. I can test it easily because, look, it's tiny. But the thing is, if you only test those little points and you don't look at the connections between them and what's going on in the connections between them, you're missing a whole bunch of the complexity of the system, which means that you're going to have a problem, and you may only discover that problem when you get to production, which is not ideal. And really, it means that you know that your individual service works, but you don't necessarily have any idea whether the system as a whole works. And I think part of the problem happens as well because we have this idea that microservices are decoupled. And actually, no, microservices are definitely distributed. They may or may not be decoupled. And I think because distributed and decoupled both start with D, we imagine that if I smear my application across the network, it's going to be decoupled. No, not necessarily. You're just going to have distributed plus all of the problems that you had before. And the thing about decoupling, actually, is I think it's a bit of a fantasy. I think it's a bit of a myth. So a system, by definition, has to have some coupling in it. And Kent Beck has this interesting idea. He talks about how what you really need to be doing is not necessarily decoupling, because you need those connections. So like if you look at the pod racers, it's those two sets of connections between the different modules that make it work. And like if that purple coupling wasn't there, then you'd sort of have the two arms going off like that, and the system wouldn't actually go in the right direction. So what you need to do is not get rid of all the coupling, but understand the coupling and manage the coupling to make sure that you have the coupling in the places that you want it, and you don't have the coupling in places where it might hurt you. But then that sort of comes to the next question, which is if I need to understand the coupling, if I need to see the coupling, have I got confidence that I can do that? Now, you may remember from Star Wars Knights of the Old Republic to the Sith Lords that Kreia said, "It is all that is left unsaid upon which tragedies are built."
That was a classic, right?
Oh, yeah, I think that might have been the Star Wars film that got left unseen,
Yeah.
actually. But the point is that we have a conversation and we say, okay, here's this point of coupling and here's this point of coupling, and we forget to mention all of the other points of coupling, and then that's where we start to get problems down the line, problems in production.
So I'll just go read the docs, right? And that'll tell me where all the coupling is.
Well, yeah. I mean, you would think that the solution is just to write more down, say more, but this is not the solution. So when I started work as a software engineer, and I should say this was like 20 years ago, this was not recently, the first thing we did when we started a project was we would write documentation. We would write a design document. My first project, the design document was 500 pages long. This thing was mammoth. So you would think that our quality would be really high, right? You would think we would know exactly what all the coupling is and exactly how everything interacts. My first day of coding, I started work against the specification that was written down in the 500-page design document, and it was wrong. on the first day, it wasn't even correct. So you just can't be, you need to understand the coupling, but you don't want to understand it by writing all of these design documents that are just annoying and wrong. And fundamentally, all design documents are lies. They may be well-intentioned lies, but they're lies.
Yeah, even ours that we write.
Sadly, yeah. So then, okay, what's the solution? You've got to be trying it out. Actually playing with the service, actually using the service is really the only way to understand what it does. But then, then we have the problem, okay, so how do you try it? How do you try it out?
Yeah, we've got this paradox now, because we've said, well, you got to be able to try it out, but end-to-end testing is really hard. So what do we do?
Yeah, and fundamentally, I think if you're doing microservices, you've got to get good at testing, and you've got to get good at automated testing, because this is going to be too expensive and too annoying to do as a manual process. So if you think about what kinds of testing you should be doing, I think the test pyramid is a really good starting point to think about it. And at the top of the end-to-end pyramid are those at the top of the test pyramid are those end-to-end tests. They're very realistic. They have a lot of value, but unfortunately they're extremely expensive to write and expensive to run, which is why Eric's team was only allowed to run them every now and then. At the bottom of the test pyramid are unit tests. Unit tests are delightfully cheap to write. They're delightfully cheap and quick to run. The only problem with them is they don't necessarily give you a lot of confidence. We've all seen it, right? Where the unit tests are totally green, and actually, it doesn't work at all.
That never happens.
And so then in the middle, you've got the integration tests. So the integration tests are sort of somewhere in between. You have more confidence than unit tests, and they're less expensive than end-to-end tests. And one thing that I've seen change is that integration tests is actually incredibly fuzzy as a category. Some people mean integration tests to mean just you're testing your REST endpoints. Some people use it to mean you're testing different services together. And the boundaries are changing as well. So like if you have tests with an application server or testing REST endpoints, it used to be that those would be considered integration tests. Now they're probably categorized as unit tests. Same for tests with a database. And things like test containers, of course, are pushing this down. So a lot of things that we used to think of as expensive is cheap. But something like test containers will only get you so far. But certainly, even lower down the test pyramid are mocks. And mocks have real problems. So if I have a dependency on something and I don't want to actually spin up the something, a natural starting point is to try and do a mock. So I have a conversation with the other team, and we agree what the interface looks like.
You read the docs, right?
We read the docs. We read the 500-page design docs. And so I write a mock that does what I think their docs said would be done. And my tests are green. I'm happy. The only problem is when we actually deploy, their code doesn't look like what was written in the doc. Their code doesn't behave like what they told me. And so then we have a break, but we only discover it at the point where we do the end-to-end. And really, I think it's a bit like when Han and Luke, they dress up as stormtroopers, so they are a mock stormtrooper. And it gets them part of the way, right? For like about 5 minutes, they behave close enough to what a stormtrooper behaves like that it's okay. But then, people start to notice, wait a minute, this behavior isn't quite right, You're a little bit short for a stormtrooper, You're not actually persisting my database. Oh, this endpoint isn't actually behaving correctly.
And you end up in the trash.
Yeah, so good enough for a little bit, not really good enough for everything. So let's have a look at how, what kind of things can go wrong.
So who thinks that this could never, ever happen? Everything is green, yet things break. Everybody is with me that this is a problem that happens in reality? Yeah. All right, so let's show just a quick little demo about how this could actually break in reality here. So I've got, and if I find it here, I've got a system here where, because we're talking about Star Wars, we got to keep with the theme. Yeah, we originally started talking about, selling carpets and whatnot, but hey, Wookiees kind of look like carpets, right? Wookiees have fur. You got to, shave some Wookiees and was it stitching or what's the word? I don't quite know what the process of making a carpet is like, but there's some process. So we're gonna
knotting or weaving.
Yeah. So I'm gonna make. Let me make this a little bigger. I'm gonna make a brown carpet.
Oh, but it seems to have gone wrong.
Yeah, what happened? So I asked for a carpet and I got some exception. Oh, we're microservices, right? So we need to start up all the different services. So I'll go here and I will start up my service, which is going to knit the carpet. Knitting, that's the right verb. That's the verb. Is it
no,
knitting?
That's exactly the wrong word.
No, not the wrong. We were knitting sweaters before.
Yeah,
we were knitting sweaters.
So you knot a carpet or you weave a carpet.
Yeah.
You can't imagine how many conversations Eric and I have had about the technicalities of carpet making.
Developers are terrible at naming things. They should not leave naming decisions to developers, right? Because we just get it totally wrong. That's how we end up with variables like I and J and K and all that stuff. Yeah. So we're still not quite there. We have our weaver. We probably need fur. So let's go start our fur service. Once the fur service is up, now we can actually have a service that does something. A little off the screen here. So we have a flow where we go from our shopping service to our weaver service. Then we go out to, we need some Wookiee first, so somebody's gonna go find a Wookiee and shave the Wookiee. And that's actually a really tough process, and they don't always survive the shaving process, because Wookiees don't really like to be shaved. I don't know if you've read Wikipedia, but they don't really like that. And then we got our nice brown carpet back. And
that was kind of annoying, though, wasn't it?
We just spent 3 minutes of our time up here on stage getting everything up and running so we could actually show a demo. So this example might seem a little contrived, and we had a discussion about it as well. Would this really happen in reality, or is this just demoware to show a problem? And I think we both recounted in our experiences that this actually happened. So you feel free to nod your heads if what I'm about to show you has actually happened to you. But what I'm going to do here, and I've got lots of tests, I've got resources, but I don't know if you've noticed our accents are a little different. So I'm from the US, she's from the UK. She did a lot of the code a little bit, and so the word color here, this just doesn't look right to me.
It's correct.
Yeah, coming from the US. So I'm just going to go ahead and change this. Right? So as soon as I do that, Quarkus is running in the background. You see it's already kind of said all my tests are still passing, so all my unit tests are passing.
Tests green?
Everything is green, but now if I come back to my system and I try to order another carpet here, I got a totally indescribable carpet I did, because what happened? Our payloads and our structures don't match, and so now just kind of everything's broken, yet all of my tests and all of my different services are still green.
And that's that kind of subtle problem that can be really annoying to fix, because if you look at it, it looks right, but there's that little spelling difference, which means that the incoming service can't understand it.
Yeah, and even my test, if you look at my test here, because I'm just using Java, right? As soon as I rename something, it happily refactors throughout my entire project, and my tests are still green, and everything is still good. Now, you could say, well, you could do JSON path expressions in my test, and that might catch it. IDEs are still pretty smart, and will do string changes as well, but if you're going to get that low level with doing JSON paths, whatnot, to me, that's like a contract that you're changing, and a contract doesn't belong locally in your own system. It belongs shared between all your different resources. So.
And we're sort of seeing here that the problem with microservices, which is, that we've got two IDEs, or we've got one IDE for each service, and so if you do refactoring in one IDE, that doesn't touch any of the other services, but the interface has to go across the services. That's the point of an interface.
So now we've introduced the problem, and how would we fix that?
Yeah, so the good news
or
is...
not fix it, but prevent it from happening in the first place.
Yeah. So the good news is there are things that we can do that will kind of catch this problem early. And I think it's useful to sort of think about it by analogy with a fire alarm. So if you want to test a fire alarm, say you have the fire alarm on the Death Star and you want to know if there's a problem, if it can detect problems, then one thing you can do is, you can blow up the Death Star, and as the Death Star burns, you hear a little beep, 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 and you know your fire alarm works, which is good, except you don't have a Death Star anymore, which is bad. So in order to allow us to test our fire alarms without completely setting the thing on fire, most of us, does this look familiar to everybody? Yeah, on your fire alarm, you've got a little button, and you can push that button, and when you push that button, you get beep, beep, beep.
Kind of like a unit test.
Yeah, it's exactly like a unit test. But the problem is that doesn't necessarily give you that much confidence. Because I think we've all had the thing where you're like in the kitchen, and you set something on fire, and there's like actual flames on the stove, and the fire alarm is going, nothing to see here. So you really need to know, like, not just is the fire alarm capable of making noise, which is the unit test, but if there is fire, does the fire alarm make noise? So that's your end-to-end test.
Yeah, I mean, last time I checked, the fire's not going to come, ooh, I'm a fire, let me go warn everybody that they should get out of the house and let me push that button.
Yeah, push the button. Right. Yeah. So what you can do instead, I don't know, have any of you recognized these? Yeah, a couple of you have seen these. I often see them like in institutions, so like in shopping malls or office buildings. And what it is, it's a long stick, and there's a tiny little cup, and they sort of wrap the cup around the fire alarm, and then it puts out a little puff of smoke, and then the fire alarm goes beep, beep, beep. So you haven't set everything on fire, but you've tested that connection that you really care about, which is, if I have smoke, do I get a beep noise? And so this is really like contract testing. So you're testing the connection that you care about without having to test the whole system.
But I think it's good, though, because we're not saying that you don't want that unit test, because if you push the button and it doesn't go off, that means your sound your little speaker is busted or something. The sooner you can catch these failures, like these little individual component failures, the better. But it's not going to help you with the overall system.
And should any of you, by the way, actually want to burn a Death Star, when we were looking at pictures for this presentation, we found that you can buy Death Star fire pits for something like $3,000. So if you have a spare $3,000 and you really want a Death Star fire pit in your garden, you can do that. So going back to the test pyramid, where do contract tests fit in? I think they sort of don't fit in exactly, because contract tests give you really high confidence for really low cost. But if you had to put them somewhere, I think they'd probably be just above integration tests. So if you think about it in terms of the mocks, how we used to do it is we would have our code and their code. And what the contract tests do, really, is they give you a layer in between to mediate that interaction. So for our code, the contract test acts as a mock. But it's a really good mock, because it's a mock that then goes away and acts as a functional test for their code. So we get a mock, they get a functional test, and you know that those two are connected. It's not like my mock says it's square and their functional test says it's triangular, and no one's actually checked to make sure they're connected. So if our tests and their tests are passing, we have pretty good confidence that reality is also okay. And then, if their code changes, then our code will still pass, our tests will still pass, but their tests will start breaking, which is good, because reality would be broken. And similarly, if we start using the API in a different way, we get that really early warning that reality would be broken. So this leads us to Pact. There's a number of different contract testing frameworks. We're going to show you Pact, which I think is most widely used.
Yeah, and I think it's pretty widely used because it's pretty polyglot as well, like Java, Node, or JavaScript, Python, Ruby. It's available for a lot of different libraries and frameworks out there. So it's not just a Java technology. So go back to our demo here. So how would we fix, or not just fix, but prevent that
You
other...
need hats.
Oh yeah, we need our hats. So when we did this before, people got confused because we're working with microservices, right? And I've got one laptop and two IDEs, and like get confused as to which project I'm actually working in. So like every developer, no, I'm the C.
Sorry.
So we actually have different hats. So,
Yeah, because
so I'm the consumer.
And I am the producer. But the whole point of microservices, of course, is that they're usually not on one laptop. And the whole point of laptops is that usually two people don't share it. But
yeah.
So.
All right. So what I'm going to do. So as you can see in my test here, I'm pointing here. Like you can you can see what I'm pointing at. But we've got a mock where we've injected a mock, and then we're using good old Mockito. Everybody's familiar with Mockito for mocking our service. So when we move this to contract testing, we're actually going to move and take a lot of that stuff away. And what I'm going to do here is I'm going to drop in a few annotations that come with the Pact framework to say, hey, I want to use the Pact as my test, and this is a test for where I'm the consumer of the knitting service, and I'm a consumer for the provider of, we call it the Wiki Tamer. And the port is kind of interesting because like Holly mentioned, Pact is actually, on the consumer side, is going to stand up an actual mock. So rather than doing like an in-memory mock, it's actually going to stand up a service on the side that's going to provide me the contract. So my test is now going to make real like HTTP requests to that mock service that I'm going to define here. So the next thing I'm going to do is I'm going to create a contract. And we still haven't figured out in this day and age of AI, I've probably done this 8 million times, and IntelliJ still can't figure out which imports I want every time I do this. So let's resolve some imports here. Import a static method. I think we got one more here. Right, I think it's good. So, oops, this didn't resolve for some reason. Import class, there we go. And I'll come back and explain that in a second. And then what I'm going to do here is we've already kind of got a test, and now we have to kind of wire this test to the contract. And so now I can wire this test to say, hey, this is a test for that contract. And if we look at what the contract actually does, let me make this a little smaller here so you can see. So we define some headers, we define a JSON body for the request, and you notice we're just saying string type. So our body, we can get as specific or as loose as we want in the contract, and here we're keeping it pretty loose. We're just saying it can be any string. It doesn't really matter what it is, but we're kind of giving it an example that the mock server will return for us, in this case, brown. So when I request fur, I expect a body that kind of looks like this. And then upon receiving that request, it's going to respond with certain things. But you can see, go ahead.
Oh, no, I was just going to say, it's exactly like defining the mock, only it's a mock that then is verifiable against the actual implementation.
Yeah, and you can see the tests are already ran, and if I look at what actually happened, where's my reload from disk here? If I go and look at my file system, so there's actually another directory that's already been done, and you can see there's a JSON file that's defining the contract for me. So this is all good, but then you get the dilemma, okay, well, how do I share this, right, with my other people or other services that are interested in this kind of thing? And one cool thing that comes with Pact is this idea of a broker. So you can have a contract broker that stores your contracts that can be discovered between all of your consumers and your providers. And here I'm just using, there's a SaaS offering that they have. I'm using their free tier, but you can stand it up in a container. You can run it on queue. You can kind of do it or stand it up however you want. So I can publish this contract to the broker and pray to God that the internet works. And then when I come back to the broker and refresh,
Woohoo!
The contract is there. It says it's unverified because, like Holly said, you get kind of a functional, you get the unit test or the mock on one side, and then you get the functional test on the other side. Well, we haven't done the other side yet, but we have the contract that's here in the broker ready to be verified. You can see it looks very similar to what I just did in code. So this is more meant to be human readable, but it does have like a nice API that you could hook this into your CI/CD process and do some pretty cool things.
And if you didn't want to use the broker, the sort of the low-tech way of doing it would just be that the consumer would put the contracts into the CI of the provider.
All right, you're up, Miss.
Cool. So now we're going to show what the provider side would look like. And I hope everybody is very sympathetic before I've even started, because live coding is hard. Live coding on someone else's laptop is even harder. So what we're going to do, so as the provider, as the Wookiee tamer, I need to do something to actually make sure I work with that contract. So I'm going to make a new test class. And so I'm going to call it the FUR resource contract verification test.
Again, developers are terrible at naming things, right? We're either way too verbose or not verbose enough.
And now, the good thing about the functional tests for the provider is that they're pretty short. It's just a bit of JUnit templates. So if I do that,
the whole thing.
I'll get the template. So you can see, basically all it is saying, here's the port that I expect to be using. So that's what it's actually going to interrogate to do the validation. A little bit of setup which is basically just telling Pact, here's the port I'm listening on, and then this JUnit test template. So if I run,
You got to highlight the whole class and do the replacement. Again, live coding on someone else's laptop.
Oh, wow. Oh, I see. Yep.
Yeah,
Okay,
highlight
yeah.
the whole class.
And you'll notice that didn't normally, Quarkus, as soon as you save, it will run automatically. For that one, it didn't. We did actually have to explicitly trigger it. And that's because of how there was like a tiny little bug in the continuous testing, which is now fixed. So in the latest version of Quarkus, it will be fixed.
Control A or Command A,
Yeah.
the whole thing.
Okay, yeah. So you can see there at the bottom, we've got all 2 tests are passing. So, which is a bit sad, actually. No, that is very sad.
Yeah, just do.
Oh, it's not even. Okay, thank you.
Then
Because I should be expecting my test.
get rid of the S here.
Yay. Hooray!
And you can see it's going to the broker now.
Yeah,
It's going to the broker, picking up the contract, and it's running the test.
and it fails. So this is kind of sad that it's failing, but it's kind of good that it's failing because when we saw the actual system was broken, so we want something somewhere in there to fail. So now what I can do is I can fix it. So I can go to the skein. And I can go back here and I can correct the spelling and put back the U. And when I do that, then it's running the tests. And it should be, hooray, it is green. So the contract test caught the problem and then guided us to the solution.
Cool.
Cool.
And the other kind of cool thing, too, is if you come back to the broker now and we refresh the broker,
Oh, yes.
you can see it's green. And if we had come back in between, you would have seen this actually went red. So the fact that it failed the test, it would actually publish that back to the broker. So now you could visually see this version of this consumer and this version of this provider are broken. The communication between them is broken, so don't deploy them in the same environment because, everything's gonna break.
Yes.
You can even query it programmatically. It has a whole API. You can say, can I deploy these 2 versions of these 2 things? And it'll kind of tell you yes or no. And so you can add that to your CI/CD processes and whatnot.
And so it's quite useful for sort of understanding your backwards compatibility as well, of if I've made this change, my change broke backwards compatibility, so I can maybe deploy my change, but I need to make sure that people are still routing the old services to the old level. So I mentioned that the consumers could check their contracts and therefore their tests into the provider's CI, or if you're using a broker, that happens automatically. That can be a little bit uncomfortable for some teams because it does mean that there's an ability for these teams that are supposed to be independent to break each other. But of course, the thing is, if you don't break each other at test time, you break each other at production time instead, which is definitely worse. So, this is something that if you're going to do microservices, there has to be some sort of relationship and some sort of communication.
Yeah, better to have your colleague come walk down and tap on your cube and say, hey, this is broken, than like getting a phone call at 2 o'clock in the morning because they tried to deploy something and everything is busted.
So this model where the consumer defines the contract first and then shares it to the provider is called consumer-driven contract testing. And so basically the idea is that you have your consumer write tests. In those tests, they declare their expectations. That gets turned into the Pact contract, so that's the sort of the shared artifact. You can do this with Spring Cloud Contract as well, or with Pact. And then that contract acts as a mock for the consumer. And then on the other side, you have the provider, and that provider verifies against that contract using their contract tests, which are pretty minimal. And so this has a lot of advantages. You can do quite rich testing, much more than you could with OpenAPI. And another thing that you can do with it is you can do YAGNI. So the provider only needs to develop what's in the contract. They don't need to develop 62 endpoints just in case they're useful. They know what's needed. So it's quite TDD-like in that way. A downside is that Pact is a totally different specification to OpenAPI. So if you have OpenAPI assets, they're not really useful for this. The other thing that's maybe not ideal for some scenarios is that the provider needs to know who the consumers are so they can get contracts off them. And everybody needs to agree to use Pact or whatever is being used. So if you're Netflix or Spotify, then this isn't really going to work for your consumers to your whole ecosystem because the ecosystem is just too big. You don't know who your consumers are. And again, there is that ability to break each other. So if you have a team that's always fighting at each other and always looking for the thing where we're behind schedule, but it's that team's fault, then maybe Pact is just going to add a little bit more fuel to that fire of that dysfunctional team. And of course, sometimes, teams, they already have OpenAPI assets and they just want to use them. And so there's definitely some times when Pact wouldn't be the best choice. So if you are already in that ecosystem, or if you have a lot of consumers, then provider-driven contract testing may be a better choice. So here, you would start with the provider. They would generate, based on their implementation or their design, an OpenAPI spec. So the OpenAPI spec is the contract. And then they can verify against that OpenAPI spec using either Microx or Schema Thesis or a tool like that. And then what the consumer does is they use that OpenAPI spec to generate a mock. So again, Microx can do this, or tools like Prism can do this, and they run their tests against that mock. So you still have that connection between the provider and the consumer. And you're also using OpenAPI, which you probably already are really familiar with. The provider doesn't need to know anything about their consumers. They can just put up a web page with their OpenAPI specs. But you have a problem where if the provider has a method and they want to get rid of it, they don't have any information about who's using that method. So if they want to get rid of it, deprecation is a lot harder. And also, and I think this is really important, those OpenAPI tests, they can test the syntax, they can test the shape, but they can't do as much about the semantics as something like Pact can. And so you end up with this problem where you have things that, what was passed back from the endpoint looks the same. It looks like a stormtrooper, but the semantics are different. How it behaves is different. So you have something that looks like a stormtrooper, but instead of doing whatever stormtroopers do, it goes and rescues Leia and Wookiee and, Chewbacca. So that is something to be aware of. So let's have a look at how that might happen.
Yeah. So does everybody understand like what semantic testing means? So it's like actually looking at what's inside the payload, because like Holly mentioned, inside OpenAPI, you're just basically like type safety. Like the structure of what the thing is looks like this, but you can't do anything about, well, what is the meaning of what's inside? Does it actually make sense given this one particular request? And so when we kind of put this together a little bit, we started talking about, here we go, here's my user interface. Oops, carpet shop. So who knows what color Wookiees exist in reality?
Reality.
Reality, yeah, our reality here. We've already kind of shown brown Wookiees. Come on, you don't know Wikipedia? Come on, this should be like tribal knowledge, right? So,
let's try it out.
Yeah, how about white Wookiees? Can we do white Wookiees? Yeah, sure, we can do white Wookiees. Black Wookiees? Yeah, we can do black Wookiees. What about pink Wookiees? I mean, I've never seen a pink Wookiee. I could, or blue, the carpet up here, you probably can't see it as blue, but not unheard of I want a blue Wookiee carpet.
Yeah, totally.
We'll like pink.
Seems
Pink
reasonable.
is fun. But when I ask for a pink carpet, I get a brown carpet. So, what happened here? So we asked for pink, but yet we got brown. In this case, the tamer survived it. So I think we've kind of discovered like a functional bug here that we need some kind of dyeing service, right? Because Wookiees only exist in nature in certain colors. So there's no pink Wookiee in reality, like I said, our reality. So somebody's going to do some dyeing, and I don't think we're going to put it on the provider because they're barely escaping with their lives when they're shaving the Wookiees. So I kind of think it should be the weaver's job to, if they get some fur in, they should dye it. So in this case, you'd probably want, white fur? You'd probably want a white Wookiee fur and then dye it pink or whatever. So
yeah, so we just had like a bit of a misunderstanding because the tamer behavior there was, well, if you don't have the right thing, I will just do a fallback. And the carpet weaver wasn't expecting any fallback. They just assumed that no matter what color they would ask for, they would get that color back. So there's a missing service that we didn't spot at the design phase.
Yeah, so what I can do is I can add another test here, and I'll come back to the contract in a second, that basically says if I ask for a carpet with pink fur, then I should get back, and we're going to use different HTTP status codes here just to keep it separate. So on the consumer side, if I ask for pink fur, or the service asks me for pink fur, I'm just going to return 418. And 418 is really a meaning. Anybody know what 418 actually means in this spec? I am a teapot. Right. It's like an April Fool's joke from 20-something years ago. But what our contract says is it looks very, very similar to the other one, but the main difference, I can't highlight it, but you see where it says string value up at the top there, line 69. If we go back to the other contract, it says string type. So we're getting very specific now that in this contract, that the color, not just any string, has to be the value pink.
Yeah, if I ask for pink, I get back pink.
Yeah, and my tests are actually already failing, so I've actually discovered a bug in my application that says, hey, the contract says that if I ask for pink, I should return a 418. I'm actually getting a 500. My service is like falling over on itself because I'm not handling whatever the back-end service is returning for me. So I actually have to come in now, do what all good developers do, is surround everything by a try-catch, right? That's what we always do, right? To fix all problems. So then I can catch a web application exception. And I'll return a new not found exception. Oh, not return, throw, sorry. And say all my tests pass, excuse me, and now I can publish a new version of the contract, right? So it doesn't allow it kind of makes sense that if there's already a contract that exists, I can't just arbitrarily decide to modify that contract. I have to version it. So now I publish a new version of the contract. Now if I come back to the broker, you can see there's an unverified version 2 of the contract in the broker, which now needs to be verified, which is what Holly's going to do.
Cool. So now as the provider, I can update, because, so we've had a conversation. I was doing a fallback. I thought I was doing the right thing. The fallback was not the right thing. So instead, okay, you want a 404? I will give you a 404.
404 is always the right answer when nothing exists, right?
So if I go back to my for resource, so here you can see what it's doing is it's doing the try, it's doing a catch, and then it's doing the fallback. So instead, I can just do return null. You don't want a fallback? I will remove the fallback. And so then if we run the tests, then let's see. Let's just do you know why my tests are passing?
Yeah, they shouldn't be passing.
They shouldn't.
They should be broken.
They should be broken. There's nothing worse than
Let's just rerun it.
Rerun it.
It didn't pick up the contracts for some reason. Maybe the network. Yeah, there it goes.
Oh, okay, cool. Right, there we go. So this is a bit unexpected because, well, except that you obviously saw that I did expect it. But I thought I was doing the right thing. I thought I was doing a 404. So we said, let's not have a fallback. Let's just die if there's a problem, so I'm returning null. But actually, if we look up here, you can see that I'm going down an error path, but I'm not going down the right error path. So like even error paths that you'd think should be just like, okay, it's an error, there's actually some subtlety here. And it's returning I want to return a 404, that's what Eric expects, but instead I'm returning a 204. And so the contract, I think it would be really hard to catch that without a contract, but the contract is catching that.
But I guess in reality, there's, does anybody really care about 404 versus 204? Probably not. So we do what all good developers do. We'll go change the contract to match reality, right? Change the test so that it passes rather than fix what's actually done. So we can do that real quick. And I can come back into here. So instead of saying, where is it here? In my contract, instead of returning not found, I can tell my mock just to return no content.
And so now we're going to be green.
We can high five, and our contract now matches reality. But no, so my service is now broken. I don't handle 204 correctly. So now we've got kind of this conundrum where we're both broken, and we tried to make the contract match reality, but our services don't handle the contract. So we need to kind of have a conversation with each other about what to do here.
Yeah, and so it's sort of, it's showing that some of these problems that seem so simple can actually be quite hard to fix because there's multiple things. And so this seems like quite a contrived example, but it actually happened pretty much literally this, where I was working on a demo and it was really late at night and I had this code and I wanted to make it return a 404 and I couldn't, and it was returning a 204, and I was like, I don't care, it's late. And Eric started going on about how 404 was correct and it shouldn't be 204, and I was like, I do not care, it is late at night, I don't want to talk about 404 versus 204. I'm just going to change my expectations and be done and go to bed. And I changed my expectations, and because it was a mock, and because my code actually couldn't handle the 204, the tests saved me from having a broken implementation.
So yeah, and this is literally inside sneak peek of life at Red Hat, because this was an actual conversation that we had with each other. There we go. It's advancing. All right, let's wrap up.
Yeah.
Because they're giving us dirty looks.
Yeah. So basically, microservices testing, if anybody tells you it's easy, then it's not. The solution isn't to do more and more end-to-end testing. You really need to keep a lid on your end-to-end testing. You also need to do more than mocks. Mocks aren't going to be enough. But contract testing can be a really nice thing in the middle that can avoid a lot of problems. And with that, I think we're done. If you'd like the slides, they're there. And as well, if you'd like Quarkus for Spring developers.
Yep, and don't forget, we're going to do the giveaway and book signing at the next break at 10:50. So come on by and chat with us. And thank you very much for having us.
Yep, thank you, everybody.